The model of Git is that you basically download the entire repository onto your machine before you can start doing work. But that's not really how agents work. The agent might just be looking at parts of a repository, and it might want to do minutes or even seconds of work at a time. And so if you've got to pay like a 30-second or 1-minute penalty to download a Git repository to do like a Git clone before your agent can start working, you're wasting a whole bunch of cycles.
Ben's co-founder and CTO of Mesa. Mesa's a versioned file system built for AI agents. They integrate with major AI frameworks and sandbox infra. It works with Mastra today, kind of working on a first-class Mastra workspace integration as well. And originally, Ben, I saw your co-founder launch tweet, and it just went pretty viral. It did really well. And so that's how I first heard about Mesa. So I'd love to learn a little bit more, but maybe did I miss anything from the intro? What else can you tell us about Mesa?
No, that was perfect. Well, I'm stoked to be on. It's good to see you guys. Yeah, I'm a co-founder of a company called Mesa. We build a versioned file system for AI agents. We play really nicely with a lot of AI frameworks, including Mastra. And so, yeah, I'm stoked to talk more about it.
For those of you that have been watching, you've probably seen a lot of different types of commentary and really like thought pieces around how agents should be using file systems, why a specific file system for agents is important. We've seen a few others reimagine how this works, but can you tell me a little bit about how does Mesa work? Why is having a specific file system for agents important? How does it, under the hood, tell us a little bit how it all functions.
I think the first observation that we started with is that file systems have been a really important primitive of computing for at least 50 years now. And basically every operating system that you use is built around the idea that you've got this file system, which has got folders and files. And it's a very kind of a simple notion that lets you represent like a lot of different data types. And most programs today are built around the idea that they've got access to some kind of a file system. And so I think that's one of the reasons why most of the harnesses that you see today work really well with Bash and with the file system. And more and more, the AI model providers, whether that's Anthropic or OpenAI, have been RLing their models to work really well with Bash and with the file system. So I think that's kind of like the first observation that we started with. It turns out like file systems are just a really good primitive and they work really well with AI agents. But some of the limitations that we noticed were that more and more people were running their AI agents in environments where you didn't necessarily have access to the kind of persistent file system that you would expect. So on your laptop, you've got basically a hard drive, and that hard drive is what kind of persists all of your data. But when you're running an agent in the cloud, oftentimes you're running that in like a multi-tenant backend, or you might be running that in a sandbox. And so you don't have access to the same kind of persistent disk every time your agent spins up. And suddenly, if you've got a bunch of different agents running, you've got to worry about kind of like permissioning. So which agent has got access to which data? And if you've got multiple parallel agents running on the same data, that you might have to think about versioning. So how do you make sure that if I've got two agents that are both working on the same project, that they don't override one another and they're not constantly kind of conflicting? These are some of the problems that we set out to solve when we built Mesa. And so essentially what we've built is something that we think of as being a little bit like GitHub for all of knowledge work. We've basically got like a version control system that allows you to branch so you can do drafts and approvals, but it feels just like a folder that you can connect to any application.
Which is dope.
Nice. So you're saying it's like completely version controlled essentially, but it's like a file system. All the agents can write to it, read from it with a permissioning model, of course. And that way you can just basically build a base of knowledge and it all lives in an accessible place.
Exactly.
I've seen other people try to use Git and other types of version control systems for this. Is there reasons why traditional Git doesn't foot the bill? Like, what are the reasons why it's not as good? What are some of the benefits of this approach versus trying to allow your agents just to read and write from Git?
Yeah, there are a few problems with Git. I mean, I think first and foremost, Git was just not designed for agents. And so the kind of like API surface is complex. But I think there are a number of other limitations that Git's got. So one of them is that Git doesn't work very well with large files. You may have experienced this if you've ever tried to check in like an image or something like that to a Git repository. Git will tell you, I actually can't accept large files. Because it wasn't built to work with those. And so they're kind of like hacky sideband solutions that people use for this. One of the other problems with Git is that conflicts are not first class. So if you ever have had to deal with a conflict in Git, one thing that you realize is that it could be a real pain in the butt if you've got to, like, let's say, do a rebase through a whole bunch of commits. You as a human have got to look at every one of those commits. You've got to resolve all of those locally, and only then can you make progress on your branch. And then maybe the most important thing that we've seen lately is that the kind of model of Git is that you basically download the entire repository onto your machine before you can start doing work. But that's not really how agents work. So if, for example, you're running an agent in a multi-tenant backend or in a sandbox, the agent might just be looking at parts of a repository, and it might want to do like minutes or even seconds of work at a time. And so if you've got to pay like a 30-second or 1-minute penalty to download a Git repository to do like a Git clone before your agent can start working, you're wasting a whole bunch of cycles.
But y'all sync back to those version control systems, right? Like, do you handle the workload on your end and then you sync to the GitHubs, GitLabs, or whatever? Is that how? Because everyone's using these other products. Like, how does that work?
Yeah, so that's one of the choices that you've got. So Mesa kind of owns the storage layer for you. So if you've got a product that doesn't need to be synced back to GitHub, you can just use Mesa as your storage layer. So in other words, you can create repositories which are basically the same as repositories in GitHub in the sense that they're just version directories. You can create those in Mesa. You can use Mesa on its own. But let's say you've got a coding agent use case and your customers want your branches synced back to GitHub so that they can see PRs on GitHub. We've got kind of a background sync engine that'll sync to GitHub.
That's awesome, dude. You've evolved into this idea. I would love to understand the story of like before Mesa, there was something else, and like how did that pivot happen?
Yeah, there is a little bit of a backstory here. The backstory is that when we started Mesa, my co-founder and I started the company with the idea that GitHub was not built for the kind of coming age of agents. And there were a bunch of different respects in which we thought this was true. The first thing that I think a lot of people have come to believe recently is that GitHub wasn't engineered for scale. And so you can see GitHub's having all sorts of trouble with uptime these days. But I think also we could see the GitHub UI was not really designed for the kind of super high volume agent driven workflows that people are dealing with now. So, it's not very good at rendering really large pull requests. It's got more AI features built in now, but they're not very good. Like GitHub's code reviewer has got a bunch of problems. It doesn't help you to really understand a large diff quickly. And so we tried a couple of different angles of attack on this problem where we said, well, if you were going to rethink GitHub from the ground up, what would be the best place to start? And so actually early on in the company, we built a replacement UI that used GitHub's backend. And then we went and built a whole bunch of agents that sat on top of GitHub. So we built a code review agent, for example. It had a decent amount of traction building that. But in the process of building those products, one of the things that we discovered is that actually the GitHub backend was the thing that was holding us back the most. And even when we tried to go and build code review agents, the fact that we were forced to use the Git model, the fact that we were forced to sit on top of Git as the kind of version control primitive created a bunch of difficulties for us. And so we realized maybe there was even bigger opportunity in rethinking what that storage layer looked like. And, even going down to the level of rethinking whether we should be using Git as the underlying kind of version control mechanism.
Yeah, dude, I remember, we've had many beers talking about this. Yeah, it's so cool to see the evolution because I think this is the right problem to solve in the grand scheme of destroying Git. I think this is the one that both resonates with agents, but also resonates with a bunch of people who are now experiencing where GitHub is failing us. And I don't think people will truly realize it until their agents realize it, because we're in that era where agents are kind of leading humans in these technological things. So, it's super sick. And I'm really glad that we have integration. I heard you have a demo.
I have got a demo. Hopefully this gives you a sense of why we think Mesa is an important primitive and what kinds of things you can do with Mesa that you can't typically do. So I built a little demo app here the other day. And what I want to show you is kind of like an AI financial analyst, what I call a CFO command center. So maybe you're building an agent for your finance team or for your CFO. And your CFO's got some big data room with a whole bunch of documents. And those documents might be a combination of PDFs. So these could be contracts, they could be customer case studies, a whole bunch of different things. And you've probably also got some Word docs, you've got some Excel docs, and you've got some CSVs. And so these are the kinds of workspaces or data rooms that non-technical people on your team are dealing with every day. And so you might want to give them an agent to help them do the job. And so the first thing that I want to show you is just the way that you can connect a typical agent to a repository, or in other words, just a version folder in Mesa. So we've all, probably seen these kind of chat UIs. And so I've got a CSV in here that's a list of kind of imaginary vendor contracts. And so, I might want to ask my agent where we can optimize our vendor spend. And you can see as my agent works through this problem, it's just going to be using bash. And it's, simply making calls like ls to list the results of a directory. It can cat to see the contents of a file. It can use all of the kind of standard bash commands. And what's cool is when you're using Mesa, you can either mount Mesa as a POSIX file system in a sandbox. And so in other words, it's a fully native directory, or you can run Mesa in process. And in this case, I'm running Mesa in process. And so you've kind of got a choice depending on whether or not you need a full sandbox environment. But I think we've all seen flows like this. This is relatively straightforward, and you can do this with a lot of different backing file systems. I think where Mesa gets really interesting is with some of our version control primitives. One thing that we've heard from a lot of people is that more and more people want to run agents in parallel. And so there are different reasons you might want to do this. One reason is that you've got agents working on different tasks and you want them, but those tasks might involve the same documents. Another reason is that you might want to explore a bunch of different paths and then accept one and discard some of the others. And so I'll just show you a really simple version of this. So you might have noticed that in these mock vendor contracts, we had our SOC 2 compliance done with Delve. And so we realized we actually need to replace Delve with Vanta. And so I'm going to ask my agent to go ahead and do that replacement. But in this case, instead of just launching one agent, I'm going to launch 3 parallel agents to all work in the same problem. And we'll see which one gets us the best result. And so under the hood, what's going on is Mesa has got Git-like branching primitives. And so in essence, we're going to kind of fork our file system 3 different ways. Each agent's going to get its own isolated copy of the file system, and it's going to, be free to like modify documents, look at whatever documents it wants to, and of course, it can use standard bash commands. And again, in this case, this is running all in process. But if you wanted to, you could mount Mesa in a sandbox. And I think my 3 different agents here are just different Claude models. So I've got Haiku, Sonnet, and Opus. And when these guys finish working, I'll be able to see the kind of before and after. So I'll see the diff. And you can imagine rendering this in a richer way. In this case, I just went for kind of a simple line level diff, but it would be pretty easy to render kind of like, a rich table if I wanted to and show the differences. And we can see like the cheaper, faster agent, it gave me a diff. It did replace Delve with Vanta, but it looks like it made some kind of formatting changes that maybe I didn't want. And then my Sonnet agent got a pretty good diff, and so did my Opus agent. And so it looks like these 2 guys ended up with about the same thing. And when I'm done and I'm happy with the changes that my agents made, I can now basically go from draft mode into kind of like an approved final state and do a merge much the same way that I would do in Git. And if I go ahead and refresh my vendor contracts, you can see that we've replaced Delve with Vanta. And so this is kind of an example of some of the flows that you can get into with Mesa that you wouldn't be able to do with a traditional file system.
That's really cool. Now for like a coding agent example, let's say I'm not using Git anymore. I'm not using GitHub. I'm not using Git. I'm just using Mesa. I have my code base in Mesa. And let's say my coworkers are all tackling maybe the same file, but different parts of it in our own work and stuff. And our agents are writing, but they're branching before they write. How does this like merge process work in this world where like we do want to merge all of our changes, but like, is there this whole rebase concept or like, how's that going on?
Yeah. So I think you can think of Mesa's versioning model as being like very similar to Git's in the sense that you've got like kind of chain. So in other words, you've got like snapshots of your folder that we build up over time and we're storing it in an efficient way. But at any time, you don't have to have just a linear history. You can do these kind of like forks. Every one of those forks is like a kind of a valid candidate, but probably, you've got kind of like one mainline set of changes that represents the canonical state of your documents. And so, the workflow is very similar to what you might do with Git and GitHub. I think what's really interesting and different here is that first of all, Mesa is optimized for programmatic use. And so if you want to like not just use your own coding agents, but build an agentic application, Mesa is really well set up to do that. The second thing that's really interesting is that you don't have to do a full clone before you mount a Mesa repository. So in other words, we kind of have this lazy materialization. So you could imagine you might have like a really large workspace or a massive monorepo that could take a really long time to clone. I was working on the Mastra repo today, and I mean, like the Mastra repo is pretty significant. So even that takes maybe 30 seconds or a minute to clone.
Yeah.
And so if you imagine an agent, like your CodeRabbit agent reviewing pull requests in Mastra, probably it's got to spend before it reviews a pull request. If it's looking at the entire repository, it's got to spend the first minute before reviewing any of your code, just cloning that repository. And so that's one of the problems that we solve. There are a few other interesting things that we can do. So I can talk about some of these things, but we've got kind of like real-time features. So in other words, sometimes you want to be able to like observe an agent session in real time. But I think broadly, like the focus here is just on solving the problem of how you can run massively parallel agents.
Okay, so for example, everyone's using work trees now, right? But work trees are just like, honestly, they're like clones. And if you're working in a big repo, that work tree is expensive. And now you have 10 work trees and now you're running out of disk space because you're just work treeing everything. And so in Mesa, this is not a work tree. This is a snapshot of something you touch. Walk me through like what that would look like in Mesa instead of using like a Git work tree.
Well, I think the first thing to say is that today Mesa is really optimized for use as like infrastructure. So we're not even necessarily telling people like to go and replace GitHub with Mesa. Like if you're using GitHub for your own software development, I think maybe eventually we'll go there, but today the real focus is on like the kind of infrastructure use case. But yeah, like the Mesa model of the world would be that instead of having to think about work trees, you would just say, like, I want to create a copy of this directory. You could give it some other kind of like a name, much the way that you would a work tree, but it's a lot lighter weight because work trees, while they don't store a full copy of your version history, they do still store like a full copy of your documents. And so they can be pretty expensive. And the Mesa model here is that we want to be really smart about what data you fetch. And so like in the same way that when you use iCloud or you use Dropbox, you might have like a massive amount of data in that kind of drive. So like your iCloud, your Dropbox, your Google Drive could have like a terabyte of data in it. And not all of that data is going to be pulled onto your laptop, but it feels like it's just a regular folder on your laptop. You can do the same thing in Mesa. So we're doing this kind of like smart partial materialization that's mostly transparent to you as a user.
And agents can materialize as they discover. Like if they decide they need a folder, they can materialize it and then keep going.
Exactly. And the agent doesn't even have to tell you that like it wants that folder. It can just say list the folder. And I mean, this is kind of the beauty of an actual virtual file system, not just a CLI. Like if we were a CLI just like Git, your agent would have to, check to see if the folder exists, then maybe like query an API to say, I want to pull this down. But because we're sitting at the like file system layer, because we're talking directly with the kernel, all you have to do is ask for a file, like list a repository. We've already fetched all the metadata. And then kind of like just in time, if we haven't already cached the data for that file or folder, we can pull that down from the cloud.
That's awesome.
All right, we are talking with Ben Warren, so from mesa.dev. Go check it out if you are curious about file systems for AI agents. Is the best place to follow you at BWARRN on X. I think that's right. You can go to mesa.dev.
That'll work.
All right. Any final words before we wrap up?
I'm super excited for the kind of like first class integration that we're about to launch with Mastra. You can use Mesa with Mastra today. I think it's a really awesome pairing, but I think it's going to be even better when we've got like a really tight integration with Mastra Workspace. So I think there's a lot of cool stuff coming down the pipe. And yeah, obviously sign up for the waitlist if you want to get early access. Follow me on X. Had a great time chatting.
Yeah, awesome, dude.
All right,
this
Ben.
is awesome. We're going to play with it too.
Yeah, thanks for coming on the show.
Sick. Have fun, guys.
Would you like to be a guest on the show? Visit mastra.ai/guest. Do you have a hot take, a problem you cracked, a cool product, or a demo worth watching? Share them right here on Agents Hour.